Okay, so day 2. Yesterday we talked about bases. We talked about powers. We talked about expanded form. We talked about exponent form. We talked about simplifying. We did all of that on the warm-up. Please make sure, again, notes are important. It's how you're going to study. It's how you're going to train yourself to learn the math. If you're just listening, great. Some people can just listen. Most of us cannot. You're going to have to practice putting things down on paper. The rule has been, if you write something 7 times, you can start to learn it. Okay? So exponents day 2, we're going to talk about rules. Before we go into rules, real quick though, I want to rehash expanded form. We will be using expanded form a lot today. We did exponent form on our warm-up, going from that expanded form back. Expanded is going to be very, very important. So, if I give you an example and say 3 to the 5th, and I want you to write it in expanded form, can we do that? Yeah, Grego, what am I going to do?
Put 35 times, put the number 3 5 times.
Okay, I'm going to put it 5 times, but what else do I have to put with it? Okay, what do those dots represent?
Multiplication sign.
Yeah, the multiplication sign. It's 3 getting multiplied by itself 5 times. That's wonderful. Does it just have to be with numbers? Well, no. If I say, take this to expanded form, what am I going to have?
3 x's.
Okay, so 3 x's. So this? Is that what I'm going to have?
No.
No, okay. Then, so be a little bit more specific. What am I going to do?
X times x.
Good. X times x times x. Okay. That's expanded form. That's important. So, our first rule is called multiplying like bases. Okay, so we're going to multiply things that have the same base. Remember, the base is the number that gets written over and over and over, right? Okay. I want you to come up with the rule. I'm going to show you an example. We're going to do it together. I'm going to show you another example. You're going to do it on your own. And by the third one, you should have a rule. Fair enough? Because it does no good if I'm like, here's how you do it, and then you just have it. I like you to be able to think about it. So here's my first example. I'm going to say x squared times x to the 4th. My first question to you, do we have like bases? What is the like base? Come on, I need more hands. Come on. Tell me your name.
Carly.
Carly.
X.
X. My base is x. So I'm just going to go over here, and I'm going to say it's x. Right now, though, we don't know what the power is going to be yet. We can figure this out, though. So here's what I'm going to do. These are in exponent form. Agreed? How do you think I'm going to want to change it?
Expanded.
To expanded form. So this is going to be what?
X times x.
Could be x times x. Then there's still a times. What happens to x to the 4th? Go ahead.
You put 4 x's, well, x times x times x times x times x.
Good. Okay, wait a minute. If I just showed you this, forget about up here. If I just showed you the expanded form, could you put it back into exponent form?
No.
OG.
Yes.
OG Simone, you ready? Can I change this back to exponent form? Okay, what's my base?
X.
How many are there? is this the same as this?
Yes.
Yeah, because I just changed it, right? So x squared times x to the fourth is x to the sixth power. Huh. Okay. Let's do another one. All I want you to do is put it into exponent form. We're not simplifying yet. Does everybody understand that? No simplifying, just exponent form. 3 to the third times 3 to the fifth. I'm going to give you 30 seconds before I start to work it. Try it on your own. See if you can come up with what the exponent form is going to be when I multiply like bases. The hint is change it to expanded. Change it to expanded form first. Perfect. You're doing great. Alyssa, right? You're doing great. That's fantastic. Okay, so you've had a little bit of time. Alyssa, I'm going to call on you. What's my base?
3.
3. What's going to be the power?
8.
Okay. How did you do it? Because you did a great job. I mean, it's better than my work. So what did you do?
I put it into expanded form.
Put it into expanded form. What do you have?
3 times 3 times 3
Times?
3 times 3 times 3 times 3 times 3.
And then you said, okay, well, they're all the same. The bases are all the same, so that's 3. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. Huh. Does anybody think they have a rule yet? Tammy, you think? Maddie, you think you have one? Okay, can we do one more? We're going to do one more. And then I'm going to get that rule. X to the 91st times x to the 80th. I just want you to get me into exponent form. So if you need to write them all out, ooh, that'd be a long time, right?
Yeah.
Come up with a different strategy or a different approach. So just like getting to the ball, come up with a different way besides writing them out, because we don't have time for that. What do you think you could do? Talk to the people around you. It's all right. What do you think you could do?
Can you explain why, though? No, not to me. Try to Chris. Tell Chris. Explain why.
You're gonna write them all out.
I wouldn't do that. Don't do that. Don't do that.
I could do it.
I know you can. I made a mistake. Don't do that. Who has my rock starfish? I need it. Sorry, you did great. Haley gets the rock starfish now. Okay, Haley. So Haley explained this beautifully. So Haley, first off, here's all I want. What's my answer?
X to the 171st power.
X to the 171st power. There is a rule for this. Haley, and you explained it to your table perfectly. No pressure, no pressure. You're only on video. You're only on video.
Sammy was too, so she has the apple.
Oh, nice. It's not called a rockstar apple. It will be called the wow, you're awesome as well apple. How's that? Okay. Haley, go.
Okay, so instead of writing out 91 X's, you just need to keep the base same, and it's always going to stay the same, so you just write an X first, and then instead of writing out all of them, you just need to add how many there are, which is 91 and 80, so once you add them together, it's 171.
Whoa. So you're telling me the base stays, and all we were doing was adding the powers? Wait a minute. That seems ridiculous. Let's come here. I need to double check. X squared times x to the fourth. The base stayed the same, 2 plus 4. Okay, that's just 1. Okay. 3 to the 3rd times 3 to the 5th. Well, there's 3 to the 8th. 3. Okay, I can buy that. So, the rule when we are multiplying like bases, when we multiply, now that's the key. When we multiply like bases, we keep the base and add the powers. And remember, I will go back and forth with the word powers and exponents.
You know what, Mr. H, I know you have a way of writing notes, but I'm taking notes right now too. And I think this is so important to our lesson
Absolutely.
today. In my notes, may I add
Absolutely,
something?
please.
I put stars around my rule because when I go back and study, I'm going to look at this and I'm going to go, oh man, I need to know that. We have lots of examples here, but this is the one thing, if we need to go back to that, that's really important for us to know.
Perfect. Thank you, Mrs. Armstrong. I appreciate that. I'm sure they do too.
Yes.
Because I know this. My notes are fantastic because they're all up in my head. You guys need to have good notes. Can we try an example? A little bit harder? Just a little bit. I don't want you to simplify. All I want you to do is still keep it in exponent form. We will start to simplify, but I want you to keep it in exponent form. Okay, so we have 5x squared times 5 squared x to the 9th. Remember, another way to say squared is x to the 2nd power, 5 to the 2nd power. But we can also say squared. Do I have like bases anywhere in this?
Yes.
Yes? Okay. Raise your hands. What are my like bases? David.
X.
Okay, so one of them is an x. Do I have another like base?
Yep.
Come on, I need somebody other than Haley. Haley's all you got the rock star fish. Garrett.
5.
The 5. But we have a problem already. We already have a problem. What do you think my problem is? Andy?
The problem is that I don't know.
That's right.
Yeah,
The first 5 in the problem doesn't have a power.
Oh man, the first 5 in my problem doesn't have a power. So what's the power in the first problem? 1. Why is that important? Because our rule says when we multiply like bases, we keep the base and add the power. So if it doesn't have a power, we can't add it, right? So we need to add that power in there, and we know that power is 1. Again, puppy dogs, blue skies, the sunshine, that's all things that are good. Okay, OG Simone, you ready? We already said that my 5s are like bases. So what am I going to do to find the power for out here? Well, what does our rule say?
like base, we keep the base.
Okay, so we keep the 5, and we're going to add the powers. What are the powers of my 5s? What are the exponents? Ask your shoulder partner, see if she can help you. Yeah, here's the exponent to 1. Here's the exponent to 2. You with me still?
Yep.
Okay, so we're going to add those. What's 1 plus 2? 3. So it's 5 to the 3rd. Does that make sense? Okay? Yeah, a little bit? Okay, I'm going to call on you again because I think you've got this. This is x squared, right? Got a 2? This is x to the 9th, right? Got a 9? What are we going to do to find the power now that we're multiplying those like bases? Exactly. So what's it going to be?
11.
Simone, fantastic. So I've got 5 to the 3rd, x to the 11th. That's exponent form. Is it simplified? No, because we could do 5 to the 3rd and simplify it more. But right now, all I'm worried about is exponent form. Question still. We good? Okay, moving on. Moving on, moving on. So just an example. If I've got x to the 5th times x to the 5th, you could immediately look at that and tell me that's x to the what? 10th. Because we keep the base, we add the exponents because we're multiplying. I can write this a different way. So we're going to backtrack a second. The very first example I showed you yesterday was 7 times 7, correct? And we said we can write that as 7 to the 2nd power. Does everybody agree?
Yeah.
Okay. These are exactly the same, right? Could I write this as x to the 5th squared?
Yeah.
Because, wait a minute, x to the 5th squared means x to the 5th times x to the 5th, because we keep the base, and it means multiply it by itself that many times. So x to the 5th squared is x to the 5th times x to the 5th, right?
Yes.
Okay. What if I did 7 to the 4th raised to the 3rd power? How could I write that? Bryn?
So
You got this.
3 7 to the 4th power.
Yeah, so I'd write it 3 times. 7 to the 4th times 7 to the 4th times 7 to the 4th. Do we know the rule for this? We should know the rule here, right?
Yeah.
X to the 5th times x to the 5th is going to be what?
X to the 10th.
How did you get that?
Because it just added the 5.
Because you added the 5s because we're multiplying like bases. Great. What am I going to have here? 7 to the 12th, because I keep the base. I add 4 plus 4 is 8, plus 4 is 12. Okay. Can I do another one? Okay. Let's do z to the 2nd to the 6th. Oh man, I gotta write it 6 times. Andy.
Z 6 times, but the 2nd power.
Very good. So it's going to be z to the 2nd power times z to the 2nd power, that's 2, times z to the 2nd power is 3, times z to the 2nd power is 4, times z, oh man, 5. Shoo, and I'm going downhill. I don't want to write it out that many times. I don't. But what's it going to be?
Z to the 12th, but
Wait, don't steal my thunder yet. Okay, you can steal my thunder. Here we go. So you said it's z to the 12th. How did you get that easier? Because I bet you got an easier way.
because you could times 6 to 2.
Wait a minute. You're taking this 6. What 2 are you multiplying it to?
The one above the Z.
Oh, the one above the z. So 6 times 2 is 12. Does that work for all of them?
Yep.
Really?
Yes.
2 times 5 is 10. What? 3 times 4 is 12. 6 times... No, I don't believe you. I don't believe you yet. I'm sorry. We've only known each other for 3 days. I don't trust you yet. Okay. It's going way downhill. Let's do this. Go over there. Perfect. Let's try this one. I got you here. I know that I got you here. 7 x to the 4th to the 10th. Oh. Crushing this one. I got this one. I know that I'm going to win. Your method doesn't work. I'm awesome. It's just how it works.
Oh, no.
Oh, I'm ready to catch somebody. You wanted to steal my thunder, okay? Here we go.
My phone's going off.
I understand that. You can just set it over there. Here. Okay. No, my desk. Gary, my desk. So, are we missing something? What are we missing? What power? Oh, we don't have a power to the 7, so we're going to put it what? So what could I do? What could I do if I really wanted to show everything? Andy, what do you think?
Add 1 to the 8th power.
Not quite. I could write this out as 7 to the 1st, x to the 4th times 7 to the, and keep on going, right? And write it out, write it out, write it out. But you gave me such a perfect answer. Oh, Jackson's stealing your thunder. Go, Jackson.
So I was thinking you could just add the power of 1 to 7 and then multiply 10 times 1.
Okay.
Is 7 to the 10. And then multiply 10 times 4, which would be x to the 40.
Fish. Ball. It just keeps rotating. Great job. So, if you heard Jackson said it didn't have a power. Everything has a power. Power of 1. Then he said, okay, I'm going to take this exponent that's on the outside and I'm going to multiply it to the exponents on the inside. 10 times 1 is 10. 10 times 4 is 40. Jackson, you're a rock star fish, man. It's a cool fish, isn't it? Where is it? Where is it? Okay, I just need to make sure. Okay, you ready for an example? One more. One more. Go. Oh, no.
Again, if you need to use your multiplication charts, get them out and use them, okay? That's totally fine. There you go.
Okay, Mr. Lucy. You ready? Too bad, you got it. Mr. Lucy, am I missing something inside the parentheses?
Yeah.
What?
The 7 is missing a 1.
Okay, 7's missing an exponent. So we give it an exponent. Okay? Maya, what do we do from here? Oh, that's right.
You do the power, first power to times 3.
So we're taking this 3 times the 1. Then what?
It'd be 7 to the first power.
Good.
And then it'd be 1.
What would be 1?
Like take the 0.
So what's 3 times 0?
I got stuck on that one, so I just
Okay.
put it
That's right. Do you know what's anything times 0? Help her out. 0. So that's x to the 0.
I thought you would change it to the 1.
Yeah.
No, ma'am. It still has a power. What's the power? 0. And 0 changes it to 1, yeah. Doesn't change the power to 1, it changes the whole thing to 1. What's 3 to the 9th? Or 3 times 9? 27. And?
36.
Good. Excellent. Yes, ma'am.
Since you have to change the x to the 0 to a 1, would you also have to change it to 3 because it's in parentheses?
No. So we don't change the power to a 1. We change that whole thing to a 1. So if we changed it before we multiplied, it would be 7 to the 1st times 1
Yeah, but
times y to the 9th times z to the 12th. Then it would have an exponent. 1 to the 3rd power is 1 times 1 times 1, which is still 1. So we don't change this power to 1, we change the number to 1. It's a great question.
But that's when you simplify.
That's only when you simplify, exactly. So, I'm just going to show you one quick example. If I've got 2 squared squared, and I tell you to simplify it. Simplify it. You're going to say, okay, well, I know that 2 squared squared is going to be 2 to the 4th. Then you're going to have to simplify it. And you're going to have to say, okay, well, 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. That's my answer. This right here is the answer to this beginning problem. That's simplification. Questions? So, I want to write out rule number 2. I want the rule to be in your notes. So have rule number 2 in your notes. Here we go. Let's get a different color. Let's put some stars around it. Rule number 2 is called power to a power. When you have a power in parentheses getting raised to another power. Okay, so again, when you have a power in parentheses getting raised to another power, you multiply the outside power to every inside power. So again, it says, when you have a power in parentheses getting raised to another power, you multiply the outside power to every inside power. So again, our example, x to the 5th is inside parentheses. My 5 is the power, getting raised to a 2. We take that 2 and multiply it to the 5. We got x to the 10th. But what happened when we had a little bit bigger problems? We had 7 to the 1st, x to the 4th, raised to the 10th. We take that power of 10 and multiply it to every power on the inside. The 1 gives me 7 to the 10th. The 4 gives me x to the 40th. Questions? Okay.